Hello. So today we are going to talk about acceleration. Um, Acceleration is when your speed is changing, or when your velocity is changing. In a car, uh, when you press on the gas, some people will say you press on the accelerator, because when you press on the gas, your speed goes changes. You get faster and faster and faster. Um, but what's hard for students to understand is that the brake is also an accelerator, especially according to physics definitions, because when you step on the brake, you also change speed, change velocity. You get slower. And change in speed is change in speed. Whether you're getting faster or slower, a physicist is going to call this acceleration. Now, there's a way to determine mathematically if you are speeding up or if you're slowing down, and how to tell otherwise. So, your formula is pretty straightforward. The average velocity, the average acceleration, how much you're speeding up or slowing down, is the change in velocity over your change in time. So you have to know your final velocity and initial velocity in a given situation. You have to know how much time has passed in that given situation. But it's also worth looking at the units here. I typically denote my units in brackets. Just, I picked that up somewhere along the way. So the units of velocity are meters per second. The units of time is obviously seconds. And if you do the algebra, if you are dividing by something, you're multiplying by the inverse of that. So you put that together, and the units of acceleration are meters per second squared. Some people in some books and some things will say, oh, it's meters per second. Same thing, same thing. English units, sometimes you'll see feet per second or feet per second squared, which again, we're not going to deal with in this class. So let's get into some conceptual examples and some basic math. In the example here, I have a car traveling down the road. I have a positive x direction, I have a negative x direction, and you'll know I do not have any distances labeled as of such. So I don't really know where the origin is in this particular problem in terms of a displacement. And that's okay, we can not have that right now for this set of examples. We're going to have the car go from one position to the next position, and at those positions we're going to have an initial velocity and a final velocity, and when those velocities change, it's going to take a certain amount of time for that to happen. Of course, the car's zooming along, and a lot of you are learning through Zoom, and I don't know, it just seemed kind of apropos.